Are there other places in the universe for humans to live if the Earth becomes uninhabitable? Is there a planet B? To answer this question, we met with our local astrophysicist, Dr. William Waller of Rockport. He talked about the science behind the existential threat of climate change and if we could ever have another home in the universe. On Everything We Do Matters.
What makes Earth so suitable for our life here on Earth? And my response to that is that we are the result of evolution that has proceeded over approximately 3.8 billion years here on Earth. And so we are exquisitely tuned to the conditions on Earth. We breathe the oxygen that was created by the first life forms here on Earth. We respire it, it gives us part of our energy, and we are pressurized to such a degree that we feel comfortable with the pressure of the Earth's atmosphere. The amount of gravity here on the surface of Earth, expressed as 32 feet per second, which would be the acceleration of gravity. We're very used to it. Our hearts are used to pumping against that gravity to get the blood all the way through our bodies. So yeah, we are a consequence of evolution here on Earth. What happens when you leave this amazing home, this amazing habitat that we found ourselves in? And we now do it. We go into the ocean, which is a part of Earth which is pretty much foreign to us, but we also go out into space, away from the atmosphere. And so we have to be in pressurized vehicles because otherwise we're going to have some problems. With essentially zero pressure outside because there's no atmosphere, our blood will basically boil and that's going to be very uncomfortable. I don't recommend it. And then there's the aspect of weightlessness. Here we're used to force of gravity on us because we're a mass and the Earth is a mass, and together we have a mutual force of attraction, and we feel it and we're used to that. But when you're traveling in space, you're usually in a weightless state. That has been found to have long-term effects. You're not pumping your blood against gravity. And so, yeah, they're finding some consequences, physiological consequences. They're not terribly awful except for the atrophy of your muscles. That's been a real problem because if you stay in a weightless state for a very long time, say a year, that can lead to the degradation of your musculature. And then the Earth's magnetosphere, which is this, you could say it's a part of the Earth's atmosphere, which has strong magnetic fields in it. It protects against particles coming in from outside, like the solar wind and other cosmic rays coming from exploding stars elsewhere in the galaxy. In low Earth orbit, you're not going to experience much radiation. But on trips to the moon, and if you're exposed on the moon, which has no atmosphere or magnetosphere, you can be subject to this radiation, and it can be harmful. So about these other worlds, which we can go to, I think it's going to happen, that we'll be back to the moon in just a few years, and then we're going to gird our loins and try for Mars in decades to come. We'll get there. And for Mars, they're going to have to spend some time there. But are we talking about worlds that are tuned to our existence? No, they're not tuned to our existence. The moon, for example, has no atmosphere, so that's a problem. Mars essentially has no atmosphere. You would have to terraform, and in terraforming, by trying to get plant life going, getting the plant life to respire, that way you could get an atmosphere. That's how you'd have to make that possible. And that's, you know, that's a tall order. I think it's going to be very hard. And so if you're planning on leaving Earth in the next century or so, I don't recommend it. This brings us back to the fragility of Earth, or at least the Earth's biosphere. And I want to contextualize this because many times people say, we have to save the Earth. We don't have to save the Earth. The Earth is going to do just fine. It's this big, rocky ball, which is going to continue to spin around its axis and orbit the sun. And it will do that, for the next billion plus years. Nothing that we can do will change that. But it's the biosphere, and it's a very, very thin film around the Earth. You could walk it in a day. You could start from the bottom of the ocean around 5-10 miles deep and walk vertically, if you could do that, and then go up through the atmosphere 5-10 miles. And that would be it. That's the Earth's biosphere. You could do it in less than a day if you could walk vertically. And I challenge you. So it's very, very thin. And you can see how thin it is from the International Space Station. And that's what we need to worry about. It's so thin that we have almost increased the amount of carbon dioxide in the atmosphere by 50%. It's around 44% addition to what was there before industrial times. It's always been a trace gas here on Earth, the carbon dioxide. But just imagine, we have literally increased the amount of carbon dioxide in the atmosphere by 44%. That is kind of a big deal because it's that gas, along with water vapor and methane, which produces the greenhouse warming. And there's actually nothing wrong with the greenhouse warming itself. That's what's kept the Earth's water in liquid form for most of its existence for the past 4.6 billion years. It's the greenhouse warming produced by these trace gases. But now we've upped one of the trace gases, carbon dioxide, by a significant amount, and methane is starting to rise as well. And that is leading to the situation that we have today. And that is something that requires urgent attention for us, not to save the Earth, but to make the biosphere habitable, or to keep it habitable, at least for the next 1,000 to 1,000,000 years.